Hey guys, I'm Pat Kelly. Okay, in this problem they ask us to evaluate the definite integral, and looks simple enough, looks can be deceiving. I think this is going to take us a little bit of work. Let me try to share my thoughts with you though. Is for one, when I actually get into the integration, when I get my hands dirty, I think it's going to take up a bit of work. So I'm going to approach this by first doing the indefinite integral. In other words, I'll ignore the limits of integration just momentarily. We'll get our answer to the indefinite integral, and then come back up and put in those limits of integration and find our correct answer for the definite integral. Okay? So let me start by rewriting this, thinking of it as an indefinite integral. But even before I rewrite, let's try to even get going with our strategy. So what we've been working with lately is trig expressions, and then also the powers that they might be raised to. And a lot of times those powers are our clues in terms of what direction to take. So in this case, for instance, tan to the 3 power, an odd power for that tangent usually suggests that we want to peel off one of the factors of tangent and pair it up with the dx. So let's do that. Let's begin by looking at the indefinite integral of 6. If you don't mind, of course, I'll just bring that out in front. And then tangent just squared x, because I'm peeling one factor off and pairing it with that dx, thinking ahead of how I might integrate this guy. Okay, in fact, one of the reasons we do that is because if you had an odd power of tangent, you're left with some multiple of 2, an even power of tangent, which you then rewrite using your good old Pythagorean identity. So let me rewrite now as equals 6 integral. You got to know your Pythagorean identity, even if it's tangents and secants, or cotangents and cosecants. Tangent squared ends up becoming secant squared of x minus 1. And then we still have this tangent of x, which I still like being paired with the dx. Okay. Now I got a little bit more algebra to do. I'm going to distribute through this tan x, distribute through these parentheses. So let me move down a step. And the algebra is not too hard to see here. I hope you'd agree with me. So I'm going to distribute through, but even as I do so, I'm going to rewrite this as the integral of secant squared. I'm going to break apart into secant x times secant x, and then I have that tan x. And actually you'll see I'm even going to split apart the integral at this point. My algebra should not be too difficult here for you to follow. This subtraction sign right here now then is going to be subtraction between two integrals. I still have 6, the integral, and then I'm still distributing, and I just have my 1 times tan x dx. Okay, and I'll just take a quick second to suggest it's not like you should necessarily be thinking to yourself, I should have known to do that, and known to do that, and known to do that on the fly. These are all things you try and play around with and see what works. I happen to know that this is going to work. Okay? What is important that you are following, though, is that you don't disagree with any of my algebra or even the trigonometric rewrites here with our identities. So it should all make sense to you. And why did I do it then? Now it's looking better for me in terms of my 2 integrals. With this first one, that one factor of tan x that I peeled off and paired with the dx also now has a secant of x that I'm going to pair with them. Because now I'm going to let u equal secant of x in my next step. And then du will be secant x, tan x, dx, and that's all going to collapse and look really nice. The second integral is actually something that you should know. We've boiled this down to a very straightforward integral that you should know. You should know the integral of tan x dx. I mean it. You should know it. If you have to think about it for a little bit, I'll get started with that u substitution, but you better be able to give me the answer for that one in a minute. All right, so let me continue. In fact, I'll keep this color here because I'm going to do my u substitution that I mentioned and let u equal secant of x. As I've already given away, the du then will be secant of x tan x dx, which we like because now the parentheses just boils down to du. So in my next step down here, this will equal the 6 still, the integral, the secant of x is getting replaced with u. That's all disappearing nicely as my du. So that integral is about as friendly as we can ask for, right? Okay, and then minus 6, because that was all just this one integral, and I'm picking up right there, minus 6. That gave me as long as I could. I stalled. You should know the integral of tan x. That is minus natural log of cosine of x in absolute values. All right, so that looks pretty good. And I'm going to do the integral here. That looks pretty good because it's in terms of x, okay? So I need to integrate this and also get it back to x's. That'll just take a quick step or two. So u to the 1 power, bump it up to the 2 power, divide by 2, but there's a 6 there. Let me keep this, there's a minus minus. Let's make that a plus right now. 6 natural log absolute value cosine of x. And for those out there shouting that there should be a plus c, you're probably right. But I know that what I'm going to do is come back up to the original problem and put our results of the indefinite integral in for the definite integral and plug in those limits. I'm not worried about the plus c. I'll go one more step down here and just get everything in terms of x. So 3 secant squared of x. Secant squared of x, and then our plus 6 natural log absolute value cosine of x. And plus c for those that might still be mad at me for that. But I've got a good answer for my indefinite integral. Let's come back up to the original integral then and realize I'm going to rewrite it, the original integral 0 to pi over 4 of 6 tangent cubed x dx. We now know that it equals this result of 3 secant squared of x plus 6 natural log absolute value cosine of x, all evaluated from the lower limit of 0 to the upper limit of integration pi over 4. Okay, so now let's do some plugging and chugging. And I don't even think we need to resort to a calculator for this. You know what to do with your limits of integration. We're plugging in that top value of pi over 4. And I could do this work in my head. Pi over 4 plugged into secant of x squared. I'm always thinking of secant as 1 over cosine. So cosine of pi over 4 is square root of 2 over 2. But I got to flip that because it's secant. So 2 over radical 2, but it's squared. So 2 squared up top is 4, and radical 2 squared is just 2. This is coming down to a 2. That's secant squared when I plug in pi over 4. Plus 6 times the natural log, plugging in that pi over 4 still. Cosine of pi over 4 gives us that square root of 2 over 2. I can drop the absolute values because I know that that's positive. And that's actually all just plugging in the upper limit of integration. Subtract what happens when we plug in the lower limit of 0. Usually 0 is friendlier, right? We put the 0 in. This is really, again, 1 over cosine. Cosine of 0 is 1. Squared is 1, and then times 3. I do get a 3 there. But then plus, put a 0 in here. Cosine of 0 again is 1, but the natural log of 1 is 0, right? So that's going to be a 0 there. All right, so a little bit of cleanup here. 3 times 2 is 6, plus 6 natural log square root of 2 over 2, and we're subtracting 3. And I still don't even want to resort to a calculator yet. I want to clean this up. 6 take away 3 is 3. But watch this even. I mean, I'm not trying to impress you, but I always hate to go to a calculator. This 2 in the numerator has a power of 1/2, and this 2 in the denominator has a power of 1. You can look at this as the natural log of 2 raised to the, if we subtract powers, 1/2, take away the 1, would give us a minus 1/2 as the power of 2, which is the only reason I'm getting a little bit excited about that is because we're inside of a logarithm, which means you can play with that power. You can clean up a little bit, use your properties of exponents. That minus 1/2 comes out in front as a factor now, right? So this equals the 3 still in front, minus 1/2 is coming out in front, minus 1/2 of 6 is 3, and just the natural log of 2. And that's a good looking answer, if you ask me. Okay, so we're done. The original integral, a definite integral. Really part of the challenge was knowing how to manipulate the integrand, which had the trig in it. So I saw the the odd power of tangent, manipulated it, played around, got a nice answer for my indefinite integral. And then it's plug and chug, right? But you got to make sure you do that correctly too. So that was a good one. Hopefully it helped. Try more on your own. You got to try a lot of these to really get a good hang of how to do these problems. Okay? All right. See you again.